There is something profoundly unsettling about the universe. Not because of what we see, but because of what we don't. Every galaxy you've ever seen, every star that lights the night sky, every planet, nebula, and black hole ever discovered. Together, they make up less than 5% of everything that exists. The rest is hidden, invisible, untouchable, unlit by any star. And yet, without it, the universe would not exist as we know it. Today, we are not exploring a place. We are exploring a presence, a silent architect that shapes galaxies, bends light, and controls the fate of cosmic structures across billions of years. This is the story of dark matter. Not science fiction, not speculation, but one of the deepest, most persistent mysteries in modern science. Because the universe is not held together by what we can see. It is held together by what we cannot. In the early 20th century, astronomers believed they understood the universe. Stars orbited galaxies. Galaxies obeyed gravity. Mass created motion. Simple. Until it didn't. When scientists began measuring how fast galaxies rotate, something was wrong. Stars at the edges of galaxies were moving far too fast. According to visible matter alone, those galaxies should have torn themselves apart. But they didn't. They stayed intact, as if something unseen was holding them together. At first, astronomers assumed they had made mistakes. Their telescopes weren't sensitive enough. Their calculations weren't precise enough. But the data kept coming, and the anomaly remained. Something was missing. Not a small amount, but most of the mass. In 1933, Swiss astronomer Fritz Zwicky made a radical claim. While studying the Coma cluster, he found that galaxies were moving far too fast to be held together by visible matter alone. He called the missing mass Dunkel Materie, dark matter. At the time, the idea sounded absurd. Invisible matter that doesn't emit light? Doesn't absorb light? Doesn't interact like normal matter? Most scientists ignored it. But decades later, the evidence became impossible to deny. Galaxy clusters, gravitational lensing, cosmic background radiation. Everywhere scientists looked, dark matter left fingerprints. Not through light, but through gravity. If you could remove all the stars from the universe, you would still see its structure. Vast filaments stretching across space. Gigantic voids with almost nothing inside. Clusters forming at the intersections. This is the cosmic web, and it is built almost entirely from dark matter. Long before the first stars ignited, dark matter collapsed under gravity, forming invisible scaffolding. Normal matter followed. Gas flowed into dark matter wells. Stars ignited where gravity was strongest. Galaxies formed where dark matter dictated. Dark matter did not follow galaxies. Galaxies followed dark matter. How do you prove something that cannot be seen? You watch what it does. When light from distant galaxies bends around invisible mass, we call it gravitational lensing. And time after time, the lenses are stronger than visible matter allows. The most famous example is the Bullet cluster. Two galaxy clusters collided. The gas, visible and glowing, slowed down. But the mass passed straight through, separated from the light. Dark matter revealed itself, not as theory, but as reality. Dark matter is not dark clouds, not black holes, not dead stars. It does not shine. It does not burn. It does not collapse into planets. It passes through normal matter almost completely undetected. Billions of dark matter particles may be passing through your body every second. You don't feel them, because they barely interact at all. For decades, scientists have been asking the same question. If dark matter is real, what is it actually made of? We know what it does. We know how it behaves through gravity. But when it comes to its true nature, dark matter remains invisible in every possible way. It does not glow. It does not absorb light. It does not collide with atoms like normal matter does. So scientists began searching for it in the only place left, the world of particles. One of the earliest ideas was something called WIMPs. WIMP stands for Weakly Interacting Massive Particle. That sounds complicated, but the idea is actually simple. A WIMP would be a heavy particle that almost never interacts with normal matter. It wouldn't stick to atoms. It wouldn't emit light. It would pass straight through planets, stars, and even your body without leaving a trace. Billions of them could be passing through you right now, and you'd never know. For years, WIMPs were the favorite explanation because they fit beautifully into existing theories of physics. If WIMPs exist, they could naturally explain how galaxies formed so quickly after the Big Bang. But there was a problem. Despite decades of experiments, deep underground detectors, massive tanks of liquid xenon, and ultra-sensitive sensors shielded from cosmic radiation, not a single confirmed WIMP has ever been detected. The universe remained silent. So scientists looked for something even stranger. That's where axions come in. Axions are not heavy. They are incredibly light, far lighter than even neutrinos. So light, in fact, that trillions of axions could pass through a single atom at once. Axions were originally proposed not to explain dark matter, but to solve a strange mathematical problem in particle physics. But scientists soon realized something remarkable. If axions exist, they could fill the universe in vast numbers, forming a smooth, invisible background. Exactly the kind of behavior we expect from dark matter. Unlike WIMPs, axions wouldn't collide with atoms directly. Instead, they would gently interact with magnetic fields in very subtle ways. This is why many axion experiments look nothing like traditional detectors. They resemble quiet laboratories, listening for faint signals in strong magnetic fields, searching not for impact, but for whispers. So far, axions remain hypothetical, but the search continues. Then there is a third possibility, one that is both familiar and unsettling. Sterile neutrinos. You may have heard of neutrinos before. They are real particles produced in enormous numbers by the sun, nuclear reactors, and exploding stars. Neutrinos are famous for passing through almost everything. Trillions pass through Earth every second. Sterile neutrinos would be even more elusive. Unlike normal neutrinos, sterile neutrinos would not interact through the known forces of nature, except gravity. They would be ghosts among ghosts. If they exist, sterile neutrinos could explain why dark matter behaves the way it does on galactic scales, especially in the early universe. But detecting them is extraordinarily difficult, because sterile neutrinos don't just avoid light. They avoid almost everything. And this is the uncomfortable truth scientists now face. Dark matter may not be a single particle at all. It could be something entirely new, a hidden sector of physics, a shadow world that barely touches our own. The deeper we search, the more we realize that dark matter is not just missing mass. It may be missing understanding. Dark matter shapes the universe, but it does not explain everything. Alongside it exists dark energy, driving cosmic expansion. Together, they dominate reality. Everything we know, everything we are, is built on a tiny island of understanding, floating in a sea of the unknown. Dark matter does not threaten us. It does not watch us. It does not care. And yet, without it, we would not exist. It is the quiet hand behind creation, the invisible architect of galaxies, the reason the universe has structure at all. And the greatest question remains: if most of reality is invisible, what else have we not yet learned to see? The universe is not finished revealing itself. And dark matter is proof that the greatest truths are often hidden in the dark.